Okay, next we discuss on the relationship of current inside the transistor. The BJT we have 3 terminals. So for each terminal we have current value. This denoted as the IC. IC is collector current, IB is base current, IE is emitter current. So for the NPN, the direction of emitter current is towards the downward, and then IB always pointing in towards inside of the BJT, and IC is in the same direction of the emitter current. So okay, so you have here the transistor current. You have three transistor current. The three current is IE, IC, and IB. So this is the relationship between IE, IC, and IB. So IE is equal to IC plus IB. Okay, if you want to relate with the operation of transistor explained in the previous video, okay, you know that emitter is the one that emits the electron. So this is the one that produces all the electron. So some of the electron will be used, or will be changed to, will be the one that contribute to the base current, and most of the electron from the emitter will contribute to the collector current. So the total of collector current and the base current will be the produced or the emitted electron at the source, which is at the emitter. So IE equal to IC plus IB. Okay, if you want to see it from the point view of KCL, so you see here IB is going in, IC is going in, but IE is going out. So you have a KCL here. So this is a KCL, just a simple KCL. So, and then this is general, this is widely accepted rule. So usually IB is very small compared to IC and IE. Okay, in general IC and IE in milliampere, however IB is in microampere. Okay, so if you have, let's say you have IC is 2.5 milliampere. If you have the IC 2.5 milliampere, okay, and then IB is, okay, IB is, let's say 20 microampere. Okay, so you get IE is equal to 2.5 milli plus 0.02 milli. This is 2.52 milliampere. So IE will be almost equal to IC. So, okay. And then IC is controlled by the BE voltage, but to be precise, actually IC is controlled by the IB, the base current. Okay. Next in this slide show we explain about alpha and beta. What is alpha? Alpha is the portion of emitter current that survive after passage through the base to become collector current. Okay, so alpha referring to the survival rate. So emitter is where the electron is produced, and then the produced electron should arrive at the collector, but not all the electron arrive at collector. Some will be disappeared and become base current. So here the alpha is the survival rate. If the alpha is 0, means that all the produced electron at emitter arrive at collector. Okay, if in example of the previous slide, so we have here IC is 2.5 milliampere, and then IB is 20 microampere, and then IE is 2.52 milliampere. So you have alpha is equal to IC over IE, 2.5 over 2.52. So this is 0.99. So means most of the electron or most of the current survive and then arrive at the collector current, the collector terminal. Okay. So and then we have beta. What is beta? Beta is DC current gain. Okay, current gain. So the gain, the definition of the gain is the output over input. Okay. The gain actually means that how much the output is being enlarged or being amplified with respect to the original input. So this is gain. Okay. In the DC operation of BJT, the output signal is the IC is collector current, and then the input is base current. So the gain here is IC over IB. Okay, the last one is characteristic of the three region. We have the saturation, which has high base current. Why the base current is high? Because the both junction, base emitter and collector base junction, is in fault bias. So most of the carrier diffuse towards the base, and then it will produce total high base current. Okay, and then the IC is maximum, so because the resistance is very low. And then here the cutoff is means that both base emitter and collector base are in reverse bias, so there is no electron move across the PN junction, so there is no current, collector current, and no base current. So and then the last one is active. Active is where the base emitter where the base emitter is in fault bias, and then collector base in reverse bias. So in this case, the current is not zero. There will be a certain current, but the resistance is high because collector base is in reverse bias. So how the current still can flow even though the collector base is fault bias? Because of explained in the previous slide. So this is N, PN. So this is reverse bias, means that it's apply positive here. This is okay, this is negative. So what happened is electron from the emitter move to the p-type base. So when it moves towards the p-type base, so there will be many electrons here. Okay, and then although the depletion region between the collector and base is quite large, this apply positive will pull the electron. Okay, pull the electron, so it will cross the depletion region and arrive at the collector. So that's why there is a current flow.